Please be back to our meeting room. We need to continue our study. Okay? Yeah, thank you. So I will invite somebody to help me to figure out this problem. Okay? So let's say Kawata, and the last three digit is 205. Kawata? I'm not so sure. Okay, anyhow, the last three digit of your ID is 205. Please tell me how to figure out how to solve this problem. 205, if you don't reply to me, I will regard you as absent, okay? 205. No? Not here? So 205 is not here. How about 206? No, I asked 205, so it's not 128. So how about 207? Asmita. 207. Asmita, are you there? Are you here? Asmita. No, still not with me. Okay. So 122. Hema. 122. Are you there?
Yeah.
Thank you very much. Okay. So can you try to tell me how to draw the pressure volume of curve ABC? You can do it separately. Yeah. First, the easy one. BC, ABC, the left water. Or for white water.
Okay.
Do you know the pressure
vertical
volume? What?
In vertical direction, Fy equals to 0.
For the vertical?
Yeah, vertical direction. Fy equals to 0.
Y equal to 0? Y is equal to 0.
Fy.
Fy equal to 0. Why? I mean, we have the vertical, right? The vertical part. And which curve? ABC. You got left water and right water. Which one you analyze now? Left one and right one. So easier. So
right
maybe
one.
we can, right one. Yeah, curve ABC, because here you got no water, you only got white water here. So, and then continue. Thank you very much. Continue.
And then equals 0, F equals to 0, Fv minus F1.
Minus 1?
F1. F equals to 0, Fv minus F1 minus weight.
Yeah, weight.
Yeah. So equals to Fv equals to F1 plus W.
Yeah, I know, but we don't need to do this every time. Yeah, I just ask you how to just help. We just try to show you how to find out the horizontal and the vertical, right? So we use the float block right here, right? And then you got F1, you got F2, right? But we don't need to do it each time. That will be tedious. You can just tell us just directly, because for example, the FV, we just know that we need to find out the pressure volume, and then the vertical force. The vertical force will be equal to the weight of the pressure. So can you tell me the pressure volume? The pressure volume is actually from the curve above the curve BC to the free surface, right? The pressure volume, just like here. Sorry, I think here. Okay. we just continue. Okay. The pressure volume actually is above the curve AB to the free surface. So the vertical force is equal to the weight of the pressure volume. So
Wait, mg, that's mg.
yeah, the weight of the pressure volume. So it's important to find out the pressure volume. Why it is equal to the weight of the pressure volume? You just do what you just said. We isolate a fluid block, and then we can draw FBD, use the equilibrium equation. We find out the vertical force is equal to the weight of the pressure volume. But you don't need to do the analysis. You just use the conclusion directly. So you only need to find out the pressure volume. That's why here I want you to find out the pressure volume. Okay, I just want you to find out the pressure volume for white water for curve BC because AB, there is no water, right? So there will be no force by the fluid on curve AB, I mean, right hand side. And for BC part, for BC part, the horizontal force should be equal to what? Can you tell me? For BC, curve BC, the horizontal force will equal to this will be part. Will equal to what? For BC, the horizontal force will equal to the force on the projection, vertical projection area B prime C, right? We just do the verification. We derive this horizontal force on curve BC is actually equal to the pressure force on its vertical projection area B prime C, right? And its vertical force is actually equal to the weight of its pressure volume. The pressure volume is here is actually equal to the above the curve BC to the free surface, right? And you can use this fluid block and draw FBD and then use the equilibrium equation. Definitely you will obtain the same solution, the same answer here. And you can use it directly. Okay. Maybe this one is a little bit difficult. I'm not so sure, but you need to figure out. Okay. You need to figure out this. You just can just review the video, the records, and review the PPT, review the textbook, the ebook, okay? And then you should figure out this, okay? You don't need to draw FBD of the fluid volume every time. That will take time. That will take time. I don't think you need to do that every time, okay? So for white hand side, for white part, okay, BC. How about ABC, left water? Left water, because there are waters on both sides of the curve ABC, so we need to consider the water force of each side independently, each side respectively, and then calculate the resultant force. For left water, we have ABC. So again, we need to split curve ABC into two parts. For AB, the upper part, we here we only calculated the vertical force. So AB, the force is actually, the vertical force is actually equal to the weight above the AB, curve AB to the free surface. So here we use the shadow to indicate the pressure volume of curve AB. It's a true pressure volume, okay? So it's a true pressure volume. That means the vertical force downward. Why? you still can isolate the fluid block by its projection area, horizontal, vertical, and draw FBD and use equation using equilibrium equation, and you will get the same answer, but you can use it directly. So the vertical force is actually equal to the weight of the pressure volume. Here we got a wheel fluid is true pressure volume, and the direction is downward. Okay, this is AB. How about for BC? For BC, the section BC, and you can just isolate, use BB prime C, and use this isolated block, fluid block, and then draw FBD, use equation of equilibrium, and you will obtain the same answer. But I strongly suggest you not to do this every time. Just use the conclusion directly. For curve BC, the vertical force is equal to the weight of the pressure volume. The weight of the pressure volume is actually above curve BC to the free surface. Okay, so again, the shadow part. Okay, so it's upward. It's empty pressure volume because we don't have wheel fluids above the curve BC. So it's empty pressure volume. It's upward, downward, upward, and then this section cancel out, right? Because this downward, this is up, and then we will have curve AB. Say the vertical force on curve ABC is actually equal to the weight of the fluid block ABC. Again, I repeat, the vertical force by the left water acting on curve ABC is equal to the weight of the fluid block ABC. Why? We just do it step by step. And for curve ABC, we need to cut it into two halves. Why? Because according to what we have learned before, for curve ABC, the pressure is always perpendicular to the surface, right? So for this part, it's actually downward. And for this part, the pressure force is this way, right? It's upward, it's a vertical force, okay? So that's why we cut it into two halves and then we analyze section AB, section BC, okay? So this is the vertical force by the left water on curve ABC. How about white water? Yeah, it's obvious, very simple, because here for BC, because for AB there is no water by the white side, so only BC. For BC, the vertical force on curve BC will equal to the weight of the pressure volume. The pressure volume is actually from curve BC, above the curve BC to the free surface. So this one is downward, is true pressure volume. And so we combine, we calculate, we sum them, left water plus right water, and then you see up, down, word, and then half of them cancel out. Finally, from the curve ABC, the vertical force on curve ABC is actually equal to the weight of the fluid block B block. Okay. Okay. It's equal to B block. This is a vertical force. How about the horizontal force? Can you calculate the horizontal force? on curve ABC, the horizontal force it respectively ABC left water. So for the left water, the horizontal force will be the equal to the vertical projection area, right? A, we use this, okay, we use this, okay, let's do this. A prime and C prime, right? And this is the vertical projection area. The horizontal force will equal to the centroid of the vertical projection area, this B prime. So will equal to P B prime times the area A prime C prime unit width, right? And it should be to the right, right? How about white water? The horizontal force by the white water. Sure, again for AB, there will be no force by the white water, right? So only BC. BC again should equal to, this is V double prime, okay, for the white water. This will be its vertical projection area. So double prime C, this is the vertical projection area, and it's this one we say we use D, right? D prime, okay. It's centroid, okay. So the horizontal force by the white water will equal to P D prime times the area double prime C. So what will be P B prime? I mean, for the left water, the vertical projection area is A prime, C prime, and centrally is B prime, and so the pressure will equal to gamma D half D, right? Times A prime C prime is total D, right? This is the pressure force, the horizontal pressure force by the left water. And the horizontal force by the white water, what will be? It will be D prime times the area. This one, the centroid will be gamma D force, right? Times its area, right? And this is to the left. So the resultant horizontal force on curve ABC will be gamma. This is by the left water. And this will be half water. Right, this will be the resultant horizontal force. Do you have any question about this one? Do you have any question about this one? If you got no question, we will go forward, go on, and then this one you need to do it by yourself and then submit online. Okay, my question is, you need to calculate the horizontal force on curve ABC and calculate the vertical force on curve ABC. Okay? Oh, sorry. this one. Okay, we go forward, move on, and then I will leave you 10 minutes to do it and submit online. Okay, please decide the corresponding pressure volume for curve ABC. For this one, which one? Please decide the corresponding pressure volume curve ABC. For curve ABC, we need to split into two halves, right? AB and BC, right? For AB, the pressure volume, right? ADEB, right? Above curve AB to the free surface is empty pressure volume is upward, right? Because the pressure force. And for curve BC, will be true pressure volume, right? It should be this one. D, which D? Yeah, this is D, okay. The answer, oh, you mean the answer is D? Let's say C and D is plus and is minus. Plus means true pressure volume. Minus means empty pressure volume. For true pressure volume means the resultant pressure force should be downward. For empty pressure volume, it means the force should be upward, okay? Yeah, answer should be C. Why? Because again, for AB, we know it's empty pressure volume. It's ADEB. For AB, for curve AB, it's pressure volume is ADEB and it's minus because it's empty pressure volume. Actually, from AB, from the pressure loading, we know its direction should be upward. So it's empty pressure volume. For curve BC, however, it's true pressure volume, it's downward. It's ADEB. ADEB. C, sorry. For BC, it should be ADEBC, I think. ADEBCA will be better, right? ADEBCA. So AB plus BC, this is 2, and then you will get, it should be ABC, and it's plus, it's positive because it's true pressure volume. So the answer should be C, okay. Here, we need to find the force acting on the hemispherical covers. Oh, I forgot to mention that the center of pressure, for the horizontal force should be the center pressure for the vertical projection area, right? But for the weight, for the vertical force, its acting point should be the center of the fluid volume. Okay, should be the center of the fluid volume. Here, find the forces acting on the hemispherical covers. Here, find the force hemispherical covers. So again, we need to have the horizontal and the vertical one. Okay, so for horizontal one, we need to find its projection area, vertical projection area. Its vertical projection area should be like this one, right? The vertical projection area should be the vertical projection area, right? Should be like this. We use O1. Why? Somebody said, why not this one? You say, for this part, for this segment, the horizontal force cancel out, right? The horizontal force cancel out. for this segment, the horizontal force cancel out. For this is left, this is right? So for the curve, we still use curve A, B, C. Its horizontal force is equal to the pressure force on its vertical projection area O prime C. So for O prime C, you need to find out its pressure at the centroid and then times the area. And here it's very important. You need to find out the vertical projection area. The vertical projection area coordinate should be equal to pi r squared. This will be r. Then the area AC should equal to pi r squared, and the vertical projection area will equal to pi r squared times sine 45 degrees. Okay. This is the projection area, vertical projection area of prime C, AX. How about the F? This will be the horizontal force. Horizontal force will be equal to its this one, right? Its central pressure. Its central pressure is gamma H, and times the area. Okay. Why is minus? Why is minus? Because it should be to the left, right? It's opposite the positive x-axis. That's why here we got minus. How about vertical? Vertical, we know vertical part should be equal to the weight of the pressure volume. Again, we know for this part, for A, B part should be equal, the pressure volume should be this one, right? And for BC should be this one, right? From curve BC to above curve BC to the free surface, right? So this part cancel out. So finally, we will obtain the vertical force will equal to the volume. The fluid volume or the pressure volume, the weight of the pressure volume of this. Right. Think about it. The pressure volume. Curve ABC, above curve ABC to the free surface. So here, you need to calculate the volume of the fluid block here. The fluid block should be the half centimeter and for this section. And then how to calculate this? Here we use this one is sorry. Let me do it again. This one is actually the volume of this half hemisphere, right? And how about this one? We know it's actually should be the volume of this part. How to calculate this? Because this triangular should be equal to this triangular, right? They are similar triangulars. So for this volume is equal to the volume of this cylinder. That's why equal to pi r square h times cosine 45. Why times cosine 5? Why time? Because pi r square is actually the area of this circular, right, of this hemisphere. And then its horizontal projection area should times cosine 41. And h is a hat. So for this question, it's a little bit difficult to calculate the volume, okay? And then after you count out the volume, you can find out the vertical force. Why it's a minus? Again, because it's downward. okay? After you find out horizontal and vertical, you find the resulting force, okay? So I will give you 5 minutes to figure out this problem by yourself, and then we'll continue study, okay? Okay, I give you 5 minutes to figure out this by yourself. And then we will continue. Do you have any question about this one? Do you have any question about this one? It's a little bit difficult because this one is actually 3D. This problem is actually 3D, okay? It's not 2D case. So you need to project into, you see, for before the previous examples, usually it's unit weights, but here it's not unit weights, okay? So we need to, it's still unit width, sorry, it's still unit width, but the area, okay, we need to calculate here. It's not a unit width because it's sphere, okay. So, but it's same, the horizontal and vertical. Horizontal force is equal to the force on the vertical projection area, and the vertical force is equal to the weight of the pressure volume, okay, it's still the same, okay, but it's important how to draw the pressure volume. Here, still, you need to cut the curve, the hemisphere, the cover of the hemisphere into two parts, because one part is true pressure volume, the other part should got empty pressure volume, okay, and then you need to calculate each by each, and then sum them, okay? So we'll continue studying again because it's not face-to-face, so I don't know whether you got it or not. So to find out, figure out later on. The buoyancy force, okay, the buoyancy force, consider a body that is fully submerged, how to calculate the buoyancy force. I think most of you have learned this in middle school, right? We know that the vertical pressure force is actually equal to the weight by the fluid volume of the fluid volume, right? Just like let's do it step by step. Okay, it's fully submerged. So we got this pressure loading, right? And then again, we will try to figure out its horizontal force and its vertical force. For horizontal force, obviously, the horizontal, the left and half parts have the same vertical projection. That means they will have equal force in magnitude but the opposite direction. Okay, and so the horizontal force by the fluid on this body will be equal to 0. However, obviously the vertical pressure force is not 0 because use the pressure volume just like for this one. The pressure volume, right? The pressure volume should be this, right? It's true pressure volume, and for the lower half, so it will be this part, right? It's empty, and then the upper half cancel out. We found out actually the vertical force is equal to the fluid volume of this 3D body, right? Or we don't use the pressure volume, the conception of pressure volume. We can do this way. We choose an element area. For this element area, we know we have the force by the upper fluid and the force by the lower fluid. And then we can calculate this force on this element. Differential element will be dF equal to dF2 minus dF1. And dF2, the element force by the lower fluid will equal to P2 times the area, right? And dF1, the force by the upper fluid, will equal to P1 dA, right? And then the resultant force on this differential element will equal to P2 minus P1 times the elemental area. And P2 equal to rho g H2. H2 is actually the vertical depth to the free surface for the lower curve, and similarly rho g H1, and we found out the dF, the elemental force, the force on the elemental area will be differential element equal to rho g d volume, the elemental volume, okay? And then obviously we can do the integration. We integrating the differential element, we found that the vertical force, or we call the buoyancy force, is equal to rho g times V body. Rho is the density of the fluid. Okay, so V body is the volume of the its body. So the buoyancy force acting on the body is equal to the weight of the fluid displaced by submerging the body into the fluid. It's known Archimedes principle. Okay, this is buoyancy force. You can calculate the buoyancy force use different approach. Okay, anyhow, this one I think you should already know it in your middle school. Okay, but you can do it in other way by yourself. Okay, so for this is Archimedics principle, and we know if a body is immersed in a fluid in which its spherical weight varies with depth, the buoyancy force pass through the center of gravity of the displaced volume. It's very important. Okay, so buoyant force pass through the center of the displaced volume. For here, this is fully submerged, so it's easy to know the center of the displaced volume is actually the center of the fluid body of the solid body. But for this, it's not fully submerged. We need to pay attention here. The buoyancy force pass through the center of the displaced volume, just like here. The displaced volume is this blue one. Okay, so this one, center of displaced volume will be different of the center of this body. Okay, so also buoyancy force is only equal to the displaced volume. This so it will happen if the body of the density is smaller than the density of fluid. The body will float, right? And if they are equal, it will suspend it. Otherwise, it will sink, right? This one, we know this already in middle school. And we can use this to measure the temperature. This is its application. Okay, you can read it by yourself. We can also, because of the buoyancy, we have the submarine, and also we have not we know the story of Archimedes, right? How he know whether the golden crown is the real or have some flaws. Okay, so also a very important thing is the stability of immersed bodies. Okay, so just like here, because we know the weight and the fluid. Okay, so for the weight, we know it's pass through the centroid, of the body, and for buoyancy, it pass through the central of its displaced volume. So it will happens sometimes if B is above the arcing point, the buoyancy force is above the weight. Sometimes they are coincidence when it's neutrally stable. However, sometimes it will be lower than the acting point of the weight, and this time it will become unstable. We can easily explain this. If you have a column, this one is the density is Z1, this part is density Z2. Z1 is not equal to Z2. And we know if this into water, if Z2 is larger than Z1, definitely this one will be unstable, right? And finally, it will be, when this Z2 is Z1, and it will be stable. Okay, we know that means stable because it means it will be always return to its balance point. Okay, so anyhow, for this stability, you have learned it before, so we don't do too much exercise here, but I need you to do this and then submit online. Okay, so here you say I need you to calculate the horizontal and vertical force on curve ABC, okay? The specific gamma for the water, okay? I need you to calculate the horizontal and vertical force on curve ABC. Unit weights, okay? Unit weights. Okay? You need to submit online, okay? You need to do this and submit online. Got it? Are you there? Are you there? Are you still with me? Okay, thank you. Just do this exercise. Calculate, because this is the really, we need to know the points, okay, the key points, okay. Calculate the horizontal and vertical force on curve ABC. After you are familiar with this, for the boys say you already know it in middle school, so I don't want to spend too much time on that, okay? So you can just review what you have learned in middle school, okay? So, but this one is new for you, so please do this, okay?